if you drop an object that falls towards the earth, that is due to the direction. There is no force acting on him in the horizontal direction. So he is okay. What is dv by dt? That is the rate of change of velocity. Where we have to first find time using the distance, and then we have to use that formula. But instead this becomes the reciprocal, right? Minus of log of this value equals. In kinematics, we have learned about the motion of an object, like the velocity and acceleration related things. Now this acceleration is what we call the change in the velocity of the object. Now what causes this acceleration? That is a force. A force is what causes this acceleration. This chapter is all about force, right? We are going to learn about the basics of force, different types of forces, and what are the rules related to these forces. So that's what this chapter is all about, right? So what is a force?
Force changes the nature of motion of an object.
Yeah, force is that which changes the nature of motion of an object, but that is kind of a vague definition. Let us understand this in detail. A force can do these following things. So it can start the motion of an object. An object is at rest. Now to make this object move, we need to apply a force. For example, this ball is at rest. To make this ball move, we need to apply a force. A force is that which causes the motion of an object, right? And secondly, when an object is already in motion, to stop the motion of this object, we need to apply a force. So this ball is moving. Now to stop this ball, we need to apply a force in the opposite direction, right?
The ball will stop anyway.
Yeah, but that is due to the frictional force between the ball and the surface. There is always a friction between any two rubbing surfaces. So this friction is also a force which stops the motion of the object. In the absence of friction or any other retarding forces like the air resistance, these are all invisible forces which will try to stop the motion of the object. In the absence of these forces, so this object will continue moving forever. For example, if you go to the free space where there is no friction, no air resistance, if you set an object in motion in free space like this, now this object will continue moving forever unless a force acts on it. An object in motion will stop only when a force is applied on the object. Is that okay? And the next one, a force can change the speed of the object. An object is in motion at a certain speed. Now to increase or decrease its speed, we need to apply a force. And also a force can change the direction of motion of the object. An object is moving at a certain speed in a particular direction. To change its direction, we have to apply a force. Without force being applied, the direction will remain the same, right? The object will move in a straight line path unless a force is applied. So generally, these are the things a force can do. Simply put, a force can change the velocity of the object. That's all. So that's what we've explained in detail, right? A force can change the velocity of the object. That's it. So velocity changes, all these things will change, right? So an object is at rest, the velocity is 0. Now a force is applied, it starts moving, so velocity increases. So similarly, so velocity becomes 0. When an object is in motion, it has certain speed. Now if you stop the object, so the velocity becomes 0. So that means a force is applied, so the object has a different velocity. The velocity of the object will change when a force is applied. So that's all, right? In addition to this, there are some other things a force can do, right? Like take a soft body. Now you apply force from both the sides. The shape of the object gets distorted, right? The shape changes. The object does not move anywhere, so it remains at the same position, but the shape of the object does not change, right? So that is also one thing a force can do, but we are not getting into that in this chapter because here we are only doing something related to the motion of the object, right? So with respect to the motion of the object, so these are the things a force can do. Do you understand? So that is simply the definition of a force, okay? Force can also be understood as the interaction between any two objects in the universe. Two objects interact with each other. That means one exerts force on the other. So any type of interaction between two objects can be called a force. So there are many types of interaction. That means there are many forces in nature. But all the forces that are known to mankind are classified into 4 categories which we call by the name fundamental types of forces. The first one in this list is the gravitational force, right? What is gravitational force? So that is the force of attraction between any two objects, right? In the universe, any two objects attract each other due to this gravitational force, right? So this gravitational force is given by the Newton's law of gravitation, right? G(m)m divided by r squared. So this force between these two objects is proportional to the product of masses and inversely proportional to the square of the distance between them. So this force of attraction between any two objects in the universe is called the gravitational force, right? These are some examples of gravitational force. Now if you drop an object that falls towards the earth, that is due to the gravitational force of attraction by the planet earth, and the moon is revolving around the planet earth, that is due to the same gravitational force of attraction by the planet earth, and this earth moon system is revolving around the sun, that is due to the gravitational force of attraction by the sun. So the gravitational force is the most predominant force in the whole universe. right? So that is basically about the gravitational force. We will write few points about this gravitational force, right? So the first one is the gravitational force is an attractive force, not repulsive force. It is always an attractive force. It cannot repel. So two objects get attracted to each other, so by this gravitational force, right? Yes. And it is a non-contact force. The gravitational force works between two objects without the objects touching each other, right? No contact is required for the gravitational force to act, right? So it is a non-contact force. And the next one is, and it is a long range force. That means the gravitational force acts between objects which are separated by a long distance. Even the sun is far away from the planet Earth, right? But still it has a significant amount of gravitational influence on the planet Earth and also many other outer planets, right? So this is a long range force, right? Yes. And it is the weakest force among all the forces that exist in the nature. Though it is a very long range force, it is considered the weakest force among all the forces that we know of, right? It is very easy to separate an object from the planet Earth, right? You can easily lift an object. The heavier the object is, it gets more difficult for us to lift the object, but still it is the weakest force considering the other forces in the list, right? So gravitational force is the weakest force. So these are some of the points about the gravitational force. So that is the first type of force among the four fundamental forces that exist in the nature, okay? And the next one is the electromagnetic force. We know the force of attraction or repulsion between charged particles. Two similar charges repel each other, like these two positively charged protons, they repel each other. Two negatively charged electrons, they repel each other, and a positively charged proton and a negatively charged electron, they attract each other. This force of attraction or repulsion between charged particles is called electrostatic force. And we also have this magnetic force, right? And this magnetic force can also be produced by these moving charges. This relation and all we will learn in detail in later part of our course. Now we have this combination of electric and magnetic force, so that is called electrostatic force, okay? Now, this electrostatic force is not just restricted to objects of very small scale like the subatomic particles like the proton and electron. See, apart from the gravitational force, all the forces that are directly in our experience are only electromagnetic in nature. The basic forces like the friction between two surfaces, this friction is one form of electromagnetic force, and also the normal reaction. If you keep an object here, that stays in that position because of the normal reaction. So that normal reaction is due to the interaction between subatomic particles, right? So that is one form of electromagnetic force, and also the tension force. So all these basic forces are basically electromagnetic in nature. So this electromagnetic force is one form of the fundamental types of forces. Do you understand? So this can be both attractive or repulsive, right? Unlike the gravitational force, which can only be attractive, but this can be attractive or repulsive. So this is the second type of force, right? So the next one in our list is strong nuclear force. What is strong nuclear force? We know that an atom contains nucleus, which consists of protons and neutrons. These protons are positively charged, so they repel each other. So these protons in the nucleus, they should repel each other, but they are bound together in the nucleus. So there must be some mysterious force which binds all these nucleus particles together. So that force works against the electrostatic repulsion between these protons. So that force is called a strong nuclear force, right? So this force must be stronger than the electrostatic repulsion, because otherwise, if this force was not there, all the nucleus particles like the protons, all the protons in the nucleus, they should repel each other. That means they'll fly away from the nucleus, but they are bound together by this mysterious force which we call by the name strong nuclear force, right? So this strong nuclear force is the strongest force that we know of, right? So this is the strongest force that exists in the nature, but this is a very short range force of order of 10 to the power minus 12 meter, right? So this is a very short range force, but it is the strongest force that exists in the nature, right? So this is one force called a strong nuclear force. That is one of the fundamental forces in nature, okay? Yes. Now the next force is the weak nuclear force. So what is weak nuclear force? That is the force responsible for the radioactive decay. In the process, one subatomic particle like the neutron gets converted into a proton. In the process, it releases an electron. See, this force is not in our domain, right? We don't need to know about this force in detail, right? Just know the basic definition. Even that is not required. There is some force called the weak nuclear force. So that much you have to know. That's all. Our main concern is about the first two types of forces. In our course, we'll only be dealing with either electromagnetic force or the gravitational force. That's all, right? All the forces that we are going to learn come under these forces only, right? Electromagnetic or the gravitational force. That's it. You understand? Yes. So these are the four fundamental types of forces that exist in the nature, right? So that is about the force, okay? The last part of the chapter was about force. We did some basics of force, different types of forces and things like that. Now it is time we got into Newton's laws of motion. Shall we invite Newton into our discussion?
He doesn't look like Newton.
Yeah, this is not Newton, this is Aristotle. Let's see what he says.
To keep a body in uniform motion, an external force is required.
But this contradicts the very definition of force.
Yeah, but people believed this for about 2000 years until our Galileo performed some experiment to disprove this. He took a curved plane like this. From one side, he dropped a ball. That ball reaches the same height on the other side. Whatever is the slope of the other side, this ball will try to reach the same height. What if the other end is completely flattened? Even then, the ball will try to reach the same height, but that is not possible. So the journey of the ball continues forever until it reaches the same height. No force is applied, but the ball is not stopping. It continues moving. So that means an external force is required to keep an object moving. So this idea is discarded now. So what was once regarded as Aristotle's theory is now termed as Aristotle's fallacy. Okay? But it was Newton who gave a proper shape to this idea, which is now known as Newton's first law.
Every body continues to be in its state of rest or uniform motion in a straight line, unless acted on by an external force.
More than a law, it can be taken as the definition of force itself. See, an object at rest requires a force to start moving. An object which is already moving with a constant velocity requires a force to change its velocity. If you want to stop an object, we need a force. If you want to increase or decrease its velocity, we need a force, right? Force is that which changes the nature of motion of an object. So that is in fact the definition of force itself, right? Yes. This Newton's first law is also called law of inertia. That means the inertia of an object changes only when a force is applied.
What is inertia?
See, inertia can be roughly understood as the laziness of the object. See, you don't want to wake up early in the morning because of inertia. You are in a position, you don't want to change that position. So that is one form of inertia. See, inertia is of three types. See, inertia of rest, inertia of motion, inertia of direction. An object at rest will want to be at rest forever, right? Unless a force intervenes, so this object will continue to be at rest. Inertia of motion, an object which is at a certain speed, it will continue to be with the same speed, right? And if an object moving in a certain direction will continue to be moving in the same direction unless a force acts on it, right? So these are the three types of inertia. Let us take some examples to understand this better, okay? Our Tintu wants a car ride, but standing on the roof. So now the car is going to move. So what do you think will happen?
That depends on the speed of the car.
Yes, if the car starts very slowly, he will also move along with the car. But what do you think is the force that makes him move in the horizontal direction? That is the frictional force, right? The friction between him and the car, right? That friction is the force acting on him to make him move, right? Now, when the car starts suddenly, like this, why did he fall down? Because there was not enough friction, or there was not enough time for the friction to act. In the absence of friction, there is no force acting on him in the horizontal direction. So he is at rest in the horizontal direction, but he fell down vertically downwards because of the gravitational force. So there is some force acting on him in the vertically downward direction, but no force in the horizontal direction. So there is no motion in the horizontal direction. Initially he was at rest, now he is again at rest in the horizontal direction. Vertically he fell down because of other forces, but no horizontal force, no horizontal motion. So this is inertia of rest. Do you understand? So that is one type of inertia. Now he got little wiser and he is sitting on the bonnet, right, the hood of the car. Now with a little jerk, he somehow managed to be stable. Let's see what happens. Same result. So why did he fall down this time? See, this time he is in motion, right? A uniform motion, right? Now the car stopped suddenly, which means there is some force acting on the car which stopped it, but there is no force acting on him to stop his motion. He is already in motion, he continues to be in motion, so because there is no force acting on him, because there was not enough friction. If there was enough friction between him and the car, he would have stopped along with the car. But now there is not enough friction, so he moves continuously in the same direction, but the car has stopped because some other force acted on the car, but no force is acting on him, so he continues his motion. Do you understand? So this is inertia of motion. Okay? Yes. Now this time he instructed the driver not to apply brakes without his permission. So let's see what happens. Now again he fell down because there was some force acting on the car which changed its direction, but there is no force acting on him to change his direction, so he continues moving in the same direction, right? Inertia of direction. So the direction can change only when a force is applied, right? No force is applied on him, so no change in the direction. You understand? So a direction or the speed or the rest position. So these values will change only when an external force is applied on the object. You understand? So that is called inertia. So inertia changes only when an external force is applied. You understand? That is why we call Newton's first law the law of inertia. So these are the basics of Newton's first law. Okay? Yeah.
What happened to Tin to?
Tin to realize that it is only safe to sit inside the car, not on the roof or on the bonnet. So he learned this lesson after falling for 3 times, but on the way we have learned Newton's first law, that is law of inertia. Okay? The next one is Newton's second law, and here is Newton for you.
The rate of change of linear momentum of a body.
Wait a minute. Before we get into Newton's second law, it is important to know what a linear momentum or the momentum of an object is, because you must have learnt Newton's second law in its more basic form, like force equal to mass times acceleration. Now we will learn it in a more general sense. For that, it is important to know what a linear momentum of an object is. The linear momentum of an object, denoted by p vector, is defined as mass times the velocity of the object, right? It is a vector quantity. Mass multiplied by the velocity of the object is called the linear momentum of the object. Okay?
What's the significance of momentum?
In a way, it gives you an idea of the impact an object creates when it collides with another object. So you take an object, you drop it, it creates some impact on the ground. Now you take another object, right? Lighter object. Now you tell me which object will have more impact.
The heavier one.
No, not necessarily. Suppose the heavier object is dropped from a shorter distance and the lighter object is dropped from a higher position. Now as the height increases, the speed at which it hits the ground, so that will also be more, right, compared to this object. So the speed and the mass combined together will have some impact on the ground, not only the speed or the mass. So both together will have some effect, right? So that's why we put these two values together, right, mass and velocity. So that is the linear momentum. See, take for example, a person hit by a bullet dies not because of the mass of the bullet, but because of the speed of the bullet, right? The speed is also important. The speed and the mass put together will have more impact. So that's why mass multiplied by velocity. The direction is also important. Mass multiplied by velocity is called the linear momentum of the object. Do you understand? So this Newton's second law is about this linear momentum, and here is Newton for you.
The rate of change of linear momentum of a body is directly proportional to the force acting on it.
The rate of change of linear momentum of an object is proportional to the force applied on the object. But what is linear momentum? That is the mass multiplied by the velocity of the object. So m multiplied by v. V is a vector and so is the linear momentum. So this linear momentum mv changes when a force is applied on the object. The rate at which this changes is proportional to the force applied on the object, right? Simply F vector, right? The force is a vector. So F vector, that is proportional to the rate of change of linear momentum. So d by dt of p vector. So this p vector is the linear momentum vector, right? So F is proportional to d by dt of p. Okay, yes. Now what is p? So that is mass multiplied by the velocity of the object, m multiplied by v. So the rate of change of mv is proportional to the force. Okay, now let us take a particular case for constant mass. The mass of the object is usually constant, right? So there are variable mass cases that we will take up later at later part of the chapter, but now we will only take the mass to be constant. Okay, when m is constant, we have to do differentiation. We can take this m out, right? So F is proportional to m multiplied by dv by dt. Okay, what is dv by dt? That is the rate of change of velocity. Rate of change of velocity is what is called the acceleration. Okay, so the acceleration, so that is dv by dt. So force is proportional to the mass times the acceleration. Okay, now we will introduce some proportionality constant. So F vector equals, okay, proportional, so that means some k m a vector. Okay, so F equal to k m a vector. If you only take the magnitude of the force, right, so take the magnitude both the sides, right? So what is the magnitude of this? Denoted by simply F. So F equals k m a. So a is the magnitude of the acceleration. Okay, so F equal to k m a. Now what we do, for convenience, we take the value of k to be 1, right? So take the value of k to be 1. Okay,
Do we have the liberty to choose the value of k?
No, we don't have the liberty to choose the value of k to be whatever we want. But Newton had that liberty because he was the one who defined force, so he could choose whatever the value of k he wanted it to be. So the value of k was chosen as 1. The unit of force can be adjusted accordingly. See, if you choose the value of k to be 1, unit of force will be something. And if you take the value of k to be 2 or 3, the unit of force may be different because we have not yet defined the unit of the force, right? So choose the value of k to be 1 conveniently, and then the unit of force can be adjusted accordingly. Not convinced? See, you can make 1 equal to 100, right? You can make 1 equal to 100. Looks absurd, right? But 1 meter equal to 100 centimeter. So if you adjust the unit, 1 can be equal to 100. Right? So if you choose the value of k to be 1, you will get 1 unit. If you choose the value of k to be 100, you may get a different unit. So if you equate k to anything, any number, right? So you can take the value of k to be anything. So the unit of the force can be adjusted accordingly because we are going to define the unit only now, right? After this, we are going to define the unit. We have not yet defined the unit of the force, right? So you choose the value of k to be 1, okay? Yes. That means we will get the force equals mass times the acceleration. So this is the important form of the Newton's second law, right? Because this is the single most important formula in this chapter, right? Almost for all the questions we are going to just use this idea, right? Force equal to mass times acceleration. If you know force, you can find the acceleration, or from acceleration we can find the force, right? So this is the most important formula for this chapter. Is that okay? But remember, m is a constant value here. The mass of the object is constant here. If the mass is constant, you have to use only this relation. You understand? So rate of change of linear momentum. Okay, so that is the Newton's second law, force equal to mass times acceleration. Okay, now we'll also write few more points, right? So the next point is the unit of force. Okay, unit of force. What is the unit of force? Because we have written F in terms of known quantities, the unit of force can be written in terms of these quantities, right? Like the force equals mass times the acceleration. So mass has unit kilogram, and acceleration, the unit of acceleration is meter per second square. So that is the unit of force. That's all, right? Force has unit kilogram meter per second square. Okay, but it is so mouthful, right? Every time you want to mention a force, you have to mention 1 kilogram meter per second square, 5 kilogram meter per second square. To avoid that, we will abbreviate this, right? Instead of kilogram meter per second square, we will simply use this symbol, capital N, right? Capital N is what? Kilogram meter per second square. But what is this capital N? This stands for Newton. Okay, so Newton is the unit of force, that's all, but that is denoted by this capital N, right? So N is the unit of force. You have to remember this relation. So 1 Newton equals this 1 kilogram meter per second square, right? So this is the relation between the Newton and the known quantities, right? So 1 Newton equal to kilogram meter per second square. Is that okay? Now in CGS system, okay, in CGS system, this is MKS, right? CGS system. In CGS system, 1 unit of force is denoted by dyne, right? 1 dyne. Dyne is the unit of force, right? In CGS system. But what is CGS? Instead of kilogram, we will write gram, right? Gram. And the meter, here centimeter. Second, same, right? Gram centimeter second square. So that is the unit in CGS system. So that is called by this name dyne. But what is the relation? Let us write the relation between dyne and Newton. So gram, 1 gram is same as 10 to the power minus 3 kilogram, and 1 centimeter, so that is 10 to the power minus 2 meter, and second by second square, right? So that's all. Now this is 10 to the power minus 5, 10 to the power minus 5 kilogram meter per second square. That is denoted by N, right? The Newton. So that is the relation 1 dyne, okay, 1 dyne equal to 10 to the power minus 5 Newton, okay. So this relation may be useful sometimes, right, when you want to convert this unit, right, Newton into dyne or dyne into Newton. So we can use this relation, okay. So this is one point you have to know, and then what is 1 Newton, so that also you're supposed to remember, okay. There's one more point I want you to know, that is the force acting on an object in an interval of time. The force acts only for a particular duration of time. What is the amount of force, right? See, this formula F equal to dp by dt, so that gives you the instantaneous force, right? At a particular instant of time, what is the force, right? But now we want to find the force in an interval, but this force need not be constant, right? At different point of time, the force may have different values. Suppose this force is a constant value, right? This force is constant throughout the interval. Or if the force is a variable force, but we only need the average force, then we can use this particular formula, right? Yes. So the average force, right? Force average, right? The average force equals, now, so what is the formula for force here? So dp by dt, right? So dp by dt. But here, if you want the average force, so that is delta p by delta t. Delta p divided by delta t. So what is delta p? So that is the change in momentum of the object, right? Change in momentum. Change in momentum divided by the time duration. Okay. So this formula can be found if you want only the average force, right? The average force can be found using this formula, not the force at a particular instant of time, the average force. Or if the force is constant, it will have the same value at any point of time. So there also we can use the same formula. You want the average force, or if the force is constant, we want the exact value of force, so we can use this formula. So this is also one formula that you can remember, right? So these are some of the points about Newton's second law that you have to know. So what are the things you have to remember? The first thing is, what is force? The rate of change of linear momentum. Actually it is proportional to dp by dt, but we have taken the proportionality constant k to be 1. So that means you can write it as force equal to dp by dt, right? So not necessarily proportional, it can be exactly equal to this value. Force equal to the rate of change of linear momentum of the object, right? And also as a particular case, if the mass is constant, right? So generally the mass of the object will remain constant, right? So when the mass of the object is constant, the force equal to mass times the acceleration of the object. Alright, and then so we need to know the unit of force, which is Newton, so given by this, right? Kilogram meter per second square, right? And also we write the unit of force in CGS system, so that is 1 dyne, so that is equal to 10 to the power minus 5 Newton. So that relation you have to remember. And also this point, right? The average force in an interval can be found using this formula, change in momentum divided by the time duration. Alright, so these are some of the points about the Newton's second law, so that you have to know. Okay.
To every action there is an equal and opposite reaction.
Of all the 3 Newton's laws of motion, this is the most famous one among the common people. Everybody knows Newton's third law, if not the first and second. People think of Newton's third law as some kind of a karma or revenge. If somebody does something to you as a retaliation, you do something to that person, that is Newton's third law. Newton used these words action and reaction just for elegance. That conveys a wrong meaning. So that is very much misleading, right? There is nothing called action and reaction. There is a force and another force. Or we can say that everything in the universe is a reaction, right? There is no action. So nothing happens in the universe on its own. Maybe the only exception is Big Bang. Maybe, right? Big Bang might have happened without being triggered. We never know. But apart from that, everything in the universe happens as a reaction to something else. Let us take a simple example. Right? The simple example of walking. So you are walking. You think you are doing the walking, right? No, you are not doing anything. You are doing something to something else. As a reaction, that does something to you, that is called walking. See, simply, you are pushing the ground backwards. The ground pushes you forward. So that is what you call walking, right? Let us take this example. Our tin 2 is walking. That means he does some action. What action? He applies a force on, not himself, he applies a force on some other object, the planet Earth in this case. So that object exerts a force on him in return, so that is why he is able to move. Suppose there are no objects around, then there is no way he can move, because he can't apply any force on any other object. That means no object is there to apply force on him. So the only way he can move is having some other object, and he has to apply a force on that object. Only then that object will exert a force on him. Suppose all of a sudden Earth disappears, then he can't move anywhere, forward or backward. He will stay there forever. Suppose a mysterious rock appears in front of him. Now if he applies a force on the rock applies a force on him. So that is the only way he can move. That means everything is a reaction. If there are no objects around, so nothing will happen to you, right? So that means everything is a reaction. Do you understand? We'll write few points about Newton's third law. The first point here is an object exerts or applies some force on another object, so that object will exert a same amount of force but in the opposite direction. Equal force, which means same magnitude but direction is reversed, right? So this action and reaction are one force and another force, right? These two forces are equal in magnitude but opposite in direction, right? So that is Newton's third law. Okay, yes, but these two forces are of same nature, right? So they are not of different nature, right? One is a gravitational force, the action is a gravitational force, the reaction is also a gravitational force, or normal reaction. So these two forces are of same nature. Okay, so that is one point you have to know. And also action and reaction work on different object, right? Action is on one object, the reaction will be on different object, right? Because this force acts on that object, so the reaction force acts on this object. So action and reaction work on different objects. Do you understand? So that is one point you have to remember. Next one, the action and reaction happen simultaneously, not one after the other, right? So both these forces work at the same time, right? Simultaneously. Action and reaction happen simultaneously. So these are some of the points about Newton's third law that you have to remember. Alright, so that is about Newton's third law. Okay. Equilibrium of an object. See, an object is at rest. Now a force starts acting on the object. So what will happen? The object will start moving because there will be an acceleration due to the force. So there is an acceleration, the object will start moving. Okay, now instead of one force, there are two forces. One force in this direction, another force of same magnitude in the opposite direction. Now what will happen to the object? These two forces cancel each other because they are of equal magnitude but opposite direction, even though some force is acting on the object, but the net force is zero. So that means essentially there is no force acting on the object. So that means the object will not move. The object was already at rest, so that will not move now because there is no acceleration. But what if the object was already moving with some constant velocity and these two opposite forces act on the object? What will happen in that case?
Velocity doesn't change.
Yes, there is no net force on the object, that means no acceleration, so no change in the velocity of the object. So this condition, either the object is at rest or it is moving with a constant speed, the total force acting on the object is zero. In that case, so the object will either be at rest or it will continue moving with the same velocity. This state is called the equilibrium state. You understand? The object is in equilibrium. So when the total force acting on the object is zero, not necessarily two forces, it may be three forces, right? So these two forces act on the object. So they don't cancel each other because they are not in the opposite direction. So they don't cancel each other. Now there is a third force, right? In some direction like this. Now these three forces add up to zero. That means the total force is zero, so there will be no acceleration. You understand? So that is called equilibrium. But where should be the third force so that this total force is zero? That is a vector concept. You understand? So the resultant of those two forces, right? This force must be in the direction opposite to the resultant of those two forces, same magnitude but in the opposite direction. Or if you put these two vectors as sides of the triangle, right? So it will complete the triangle. You understand? Because the sum of three vectors is zero, so they can be represented by the sides of a triangle. Not necessarily triangle. If there are four forces, so it can be like a quadrilateral, right? Or a pentagon, hexagon, any polygon, right? So that means if many forces act on an object but the object is in equilibrium, that means the total force is zero. So these forces can be represented as the sides of a polygon, right? So that is about equilibrium of a forces. So simply remember this idea. An object is in equilibrium, that means the total force acting on an object is zero. See here, we consider the object to be a point mass, right? So only a point mass, right? Suppose you consider this as a rigid body, right? So that we will consider later on. So these cases we'll consider later on. Now for this chapter, mostly we will consider any object to be a point mass, right? So no significant geometry around it. So simply like a point mass, very small, right? Now what if the object is not a point mass? Suppose it is like this, okay, like a rod. Now two forces act on the object, two forces of equal magnitude but opposite direction, okay? So what happens? In that case, the object is still moving, right? The center of mass of the object is not moving anyway, so the total force is zero, but still the object is moving. So this is rotating, right? Even though it is not moving in a translational motion, right? So that means it is not moving in a straight line. The center of mass remains same, but it is rotating. So the object is not in rotational equilibrium. So that we have to get into the concept of torque and all. So we're not doing that here, right? Now the object is in translational equilibrium when the total force is zero. That's all, right? But that is not enough to conclude that the object is not rotating, right? If the total force is zero, still the object may be rotating, but the object is not moving in a straight line. when the total force is 0. Do you understand? That is translational equilibrium. About rotational equilibrium, so we are going to learn later only. For now, when the total force is 0, the object is not moving in a straight line, right? No translational motion. So that means that is called the equilibrium, right? Or translational equilibrium particularly. Do you understand? So that is about equilibrium of an object. For this chapter, simply remember this: an object is in equilibrium, simply the total force is 0. That's all. Okay. Let's talk about impulse. This impulse is done in detail in the next chapter only. Here we will just make a mention of what it is, right? The basic definition of impulse, that's all, right? What is impulse? That is a very large force acting in a very short duration of time, right? So that is called impulse. Like a heavy blow. Suppose a ball is coming, hit by a bat, this momentum, the momentum of the ball changes, right? This sudden change in momentum is called impulse, right? Usually when a force is applied, the momentum increases, all right? The momentum changes. This gradual change in momentum, right, the rate at which this momentum changes, that is the force, right? Here the force works only for the short duration of time, right, for which this ball is in contact with the bat, right? It is only very short duration, right? The ball is in contact with the bat only for a short duration of the time. The force is acting only in that duration, but the momentum changes suddenly. So that sudden change in momentum is called the impulse. Do you understand? See, what is force? Right? If the force is taken to be constant, during the interval of time the ball is in contact with the bat, the force is constant, suppose. Then what is force? Delta P, change in momentum divided by the time duration. You understand? Now if you multiply the force multiplied by the time duration, that is the change in momentum. So that change in momentum is called impulse. You understand? So the impulse is defined as the change in momentum or force multiplied by the time duration, the duration for which the force is working. Do you understand? So just the definition, we're not going to do anything about this impulse now, okay? We will take up this impulse later on in the next chapter. So here, simply know this definition. What is impulse? The force multiplied by the time duration. And that is also equal to the change in momentum, right? In that interval, right? The change in momentum or the force multiplied by the duration, time duration, that is called by the name impulse, okay? That's it. Conservation of momentum. See, the momentum of an isolated system is always conserved. What is an isolated system? See, that is a system with no external forces acting on it, right? See, take this example. There are two objects, one exerts some force on the other, so that means the other will also exert equal force on this one. So neither one is not an isolated system because there are some external forces acting on each of these objects. So that means it is not an isolated system. But if you put these two objects together and consider them as one system, right? So then it is an isolated system because these two forces are now internal forces between these two objects which are part of the system only. Now here, so this whole thing is an isolated system, right? So you put these two objects together, so these forces become internal forces. So that means it is now an isolated system. No external influence, right? Only internal forces. So this is an isolated system. The momentum of this system is conserved. That means whatever is the initial momentum of this object and that object put together, right? Together, not the momentum of individual objects, the total momentum of the system. That means the momentum of this object, the momentum of that object added, right? So this sum, this total will always be conserved, right? So even after some time you find the total momentum, so that will be same. Do you understand? See, what is initial momentum? Let us take the initial momentum of these two objects to be, say, P1 and P1 dash. Right, that is the initial momentum of these two objects. That means what is the total momentum? So that is P1 plus P1 dash. Okay. Now after some time, the momentum is, say, P2 and P2 dash. Right. So this total is P2 plus P2 dash. So these values are equal. This sum is equal, right? So P1 plus P1 dash. So that equals, so P2 plus P2 dash. Right. Yes. Now let us prove this. Okay. See, we know that this exerts some force F1 and that exerts force F2, but these two forces are related, right? So we know that this force F1, the force F1 equals the negative of the force F2, right? Because they are of equal magnitude but opposite in direction, so F1 equals negative of F2. Okay, yes. Now what do? You multiply this by the time duration for which these two forces act on each other, right? Yes, force, just multiply both the sides by the time duration, so T. Now what is this product, the force multiplied by time? So that is what is called the impulse, right? So impulse, so say J1, right, impulse, so that equals J2, so the impulse, okay, minus. Alright, yes, but what is meant by impulse? That is the change in momentum, right? So the delta P, so that is the change in momentum of the first object, so delta P, so that equals minus delta, so P dash for the second object, right? Change in momentum of the first object and change in momentum of the second object, so they are related, okay? But what is change in momentum? The final momentum minus the initial momentum. But what is the final momentum here? P2 minus initial momentum is P1, so that equals, so here minus of, similarly for the other object, so that is P2 dash minus P1 dash. Okay, now you bring this together, right? So P1 plus, so this one, so P2, P1 plus P1 dash, so that equals, so P2 plus P2 dash. What is P1 plus P1 dash? That is the initial momentum of the system, right? So for the first object and second object, the total momentum initially is this one. This is the final momentum, so initial momentum equals final momentum, so that means the momentum remains constant, right? So the momentum initially equals momentum finally, so that means the momentum is constant, right? So the momentum is conserved for an isolated system because no external forces act on this system. So only internal forces, no external forces, that means the momentum of the whole system, not for the individual object. The whole system has momentum constant value. Do you understand? So that is what this idea is, right? The conservation of momentum. Is that okay? We're not going to talk about the momentum conservation in detail in this class, in this chapter, right? In the next chapter, right? So later on when we do rigid body dynamics, at that time we will do more about the momentum conservation, right? For now, just know this basic idea, the momentum is conserved for an isolated system. Is that okay? Now let's take an example to understand this better. A gun is fired, right? The bullet emerges from the gun, right, with certain speed. Now we will consider this bullet and the gun to be a system, right? So this system consists of a bullet and gun. There is no external force, only force between the gun and the bullet, right? So no external force, so that is an isolated system. So that means, so the total momentum is conserved. What is the initial speed of the bullet? That is 0. Initially it was at rest. Now here the gun was also at rest. So that means initial momentum of the system is 0. What is the final momentum? Suppose the bullet comes out with a speed v, right? Mass times v. So that is the momentum of the bullet. Now similarly, the gun will also have a momentum, say mass times the velocity in the opposite direction, right? Mass of the gun multiplied by the velocity of the gun. That is in the opposite direction, so negative of that. So this total must be equal to 0. So this is the relation between the velocity or the speed of the bullet and the speed of the gun. So the bullet moves in the forward direction, so the gun will also have a recoiling force, right? In the opposite direction, it will have momentum, mass times its speed, but in the opposite direction. So this is the relation between the speed of the bullet and also the speed of the gun in the opposite direction, right? So these are some examples so where we can understand this concept of conservation of momentum, right? There will be a recoiling force due to this momentum conservation, right? If you take another example, right? So this person is walking on a plank. So this plank is on a smooth surface, right? So very smooth surface. So the force between him and the plank, so that is internal, right? That is the friction between them. So that is internal force. As the person walks with a velocity, right, say v in the forward direction, so the plank will move in the opposite direction because the momentum should be conserved, right? So mass times velocity of that person, so that equals the negative of mass times the velocity of this person, right? So that means the total momentum should be constant. Do you understand? So these are some examples to understand this momentum idea, right? Is that okay? This is an important idea, the resolution of a force or the projection of a force in a particular direction. See, this is an important concept which is used in almost all the questions. See, there is an object. A force is applied on this object, but the line of action of this force is not in the horizontal direction. It is making some angle theta with the horizontal, right? A force is acting in this direction. But suppose the object is only constrained to move in the horizontal direction, right? We want the effect of this force in the horizontal direction. We want the total force. We want the effect of this force only in the horizontal direction because the object is constrained to move only in that direction. Okay, yes. What is the projection? of this force in the horizontal direction. So this is a vector making some angle theta with the horizontal. So what is the projection of the vector? So that is the magnitude of the vector multiplied by the cosine of the angle theta, right? So f cos theta, so that is the projection, right? So that is a vector concept, right? Or you take the right angle triangle. In that right angle triangle, so that base is f cos theta, right? Or the cos theta equal to the base divided by the hypotenuse f. That means the base, that is the horizontal projection. So that is f cos theta. So this f cos theta is the horizontal projection, or the projection in the direction making angle theta with the vector. You understand? So that vector makes angle theta with our required direction. So the projection in that direction is the force or the vector multiplied by cos of this angle, right? F cos theta is the projection in the horizontal direction. Okay. Now similarly, what is the vertical projection? So this line makes angle theta with the horizontal. That means what is the angle made by this line with the vertical? So that is 90 minus theta. You understand? This angle is theta. So this angle is 90 minus theta. So that means f cos 90 minus theta, or we can say f sin theta. So the horizontal projection is f cos theta and the vertical projection is f sin theta. Not necessarily horizontal projection or vertical projection. The projection in a direction making angle theta, so that is cos theta. The projection in a direction making angle 90 minus theta, so that is sin theta, right? That is what we call horizontal projection, vertical projection. In this case, it looks like horizontal, vertical. It depends on what the angle theta is, right? If the angle made with the vertical is theta, so vertical projection will be f cos theta, right? So the projection in a direction making angle theta with that vector is that magnitude of the vector multiplied by cos of the angle, right? The perpendicular projection is f sin theta, right? So this is the first thing you have to know. So in a particular direction, for example here the horizontal direction which makes angle theta with the force, so in that direction the projection of the force is f cos theta and the vertical projection here is f sin theta. Alright, so this is the basic idea. So that is used in many questions, so you have to remember this. Okay, now for example, you take this example. So here also there is a force which is in the vertically downward direction. Can you tell me the projection of this force in the direction AB, right? In the direction AB, what is the projection? That means we just need that angle. You understand? The angle made by that f vector with the direction AB, so that angle is known, so f multiplied by cos of that angle. That's all. So what is that angle? Then is a basic geometry, right? So this angle is theta. So that means the angle made with the vertical, so that is 90 minus theta. So that means the other angle is theta, right? Because that is right angle. So 90 minus theta, theta, which means the force F makes angle theta with the line AB. So if the angle is known theta, that means what is the projection? That is f cos theta. That's all. So f cos theta is the projection of this force in the direction AB. Okay, what is the projection of the force in the direction AC, right, along that plane? So what is the projection? That is, so that angle is 90 minus theta. That means f sin theta or f cos 90 minus theta, right? F sin theta. F sin theta is the projection of the force in the direction AC, and f cos theta is the projection in the direction AB. Do you understand? Just an example. And similarly, you take this example. What is the total force acting on this object in the horizontal direction? There are three forces, not one force. You have to take the projection of all these forces in the horizontal direction. First of all, let us take F1. What is the projection? So F1 is making angle 90 degrees with the horizontal. That means F1 cos 90. That means it is 0, right? So cos 90 is 0. That means if a force is acting in a perpendicular direction to the direction which we need, okay, we need the horizontal direction. We need the resolution of the force in the horizontal direction, but the force is acting in the perpendicular direction. You need not consider that force, right? Or F1 cos 90. So anyway, that is 0. Cos 90 is 0. So perpendicular vector does not contribute to the motion of the object, right? So that means, so F1 cos 90, that is 0. So F1 is not required in the horizontal direction. Okay. Now what about F2? So F2 makes what angle? Theta. Right, F2 makes theta with the horizontal. That means F2 cos theta. So that's all. So that is the projection of F2. Now what about F3? What is this angle made by F3 with the horizontal? So let us take this direction. Okay, in this direction, what is the angle made by F3 with the horizontal but in the negative direction? So let us find. So that angle is theta, and this angle then is 90 minus theta. So again this angle is theta. So this angle is 90 minus theta, right? That means F3 makes 90 minus theta with this horizontal, but in the negative direction. That means what is the projection? F3 sin theta. You understand? 90 minus theta. That means F3 sin theta, that is the projection of F3 in the horizontal direction, but in the opposite direction. So we have to take the negative of that. We want the horizontal direction in the positive direction. So F3 sin 90, F3 sin theta, but in the negative direction. So that means you have to take minus F3, right? So F3 sin theta, so that is the projection of F3 in the horizontal direction or the positive part. Okay, yes. So that is the projection of all these vectors in the horizontal direction. Okay, now similarly, can you tell me the vertical projection? What is the vertical projection here? See, what is the vertical projection? Vertically upward. Okay, let us take this positive direction. So what about F1? So F1 is in the opposite direction. So what is the projection of that? So that is minus F1. Or you can say F1 cos 180, right? 180, because the angle made by F1 with the vertical, right, in the positive direction, that is cos 180 degree, right? 180 degree. So cos 180 degree, that is minus 1. So minus F1 is the force. Okay, now similarly F2. What is the angle made by F2 with the vertical? So that angle is 90 minus theta, because with the horizontal F2 makes angle theta. With the vertical it will make angle 90 minus theta. That means F2 sin theta. So F2 sin theta is the projection of F2 in the vertical direction. Okay. Now what about F3? So F3 makes what angle? Again theta. So F3 makes angle theta with the vertical. So that means F3 cos theta. So that's all. So F3 cos theta plus F1 sin, F minus F1 plus F2 sin theta. So that is the total force acting in the vertically upward direction. Similarly horizontal direction. So that force. Do you understand? So like that, there are many forces acting on an object, but we want the effect of all these forces in a particular direction. So we should be able to find the projection of all these forces in that direction. For that, what we need is simply the angle made by all these vectors with that particular direction. So cos of that angle will give you our required projection in that particular direction. Alright, so it's a very important idea, so you remember this. So the projection of the forces or the resolution of the forces, okay, in our required direction. Is that okay? Yes. A free body diagram is simply the diagram of an isolated body where we mention all the forces directly acting on this body. An object is usually mentioned as a point mass, and these are all the forces acting on the object. So this diagram is called a free body diagram. That's all, right? So these forces, what are all the forces acting on the object, that will be understood from the question. From the question we have to see what are all the forces acting on the object. You mention all the forces by this arrow mark. So that is called the free body diagram. That's all. Alright. Shall we use all the concepts that we've discussed so far to solve some questions? A block of mass 2 kg covers a certain distance d with a constant speed in 12 seconds. If a force of 3 Newton also acts on it along its motion, it can cover twice the distance in half the time. The value of d is. Here, in the first case, the object is moving with a constant speed. It covers a certain distance d in 12 seconds. In the second case, we also apply a force. When there is a force, there will be an acceleration. This acceleration causes a change in the velocity of the object. So there is a change in the speed. In the first case, the speed is constant. So when the speed is constant, what is the relation between speed and the distance? So the first case, when the speed is constant, then the distance d. So that equals the speed. So this is the formula. Speed multiplied by the time. So that is the relation when the speed is constant. Okay, yes. So the distance is d. That equals the speed. So let us take the speed to be v, right? That is constant. So take it as v multiplied by the time. So that is given to be 12 seconds. So this is one relation. So the first case, when the speed is constant, so this is the relation d equals 12v. Done. Now in the second case, now we can't use this formula as the speed is not constant here because we are applying a force. So there is an acceleration. When there is an acceleration, what is the relation between the distance and the speed? So s, that is the distance. So that equals, so this is the formula which you are familiar with, ut plus half at square. Alright, we have the acceleration, so that you have to substitute here and we will get our required distance d, right? But in this case, in the second case, the distance is 2d, right? Twice the distance. So here the distance is d, here twice the distance, so 2d. So that equals, so u, that is the initial speed, so that is same as this speed, right? So v, multiplied by t. So this time the time is only half the time. See here it is 12 seconds. So here it is only 6 seconds, right? So v multiplied by 6 plus half a. What is acceleration? So force divided by mass, right? Multiplied by t square. So t is 6 again. So 6 square. So force divided by m, that is the acceleration, right? As per Newton's second law, force equals mass times the acceleration. So acceleration equals force divided by m. So let us substitute the value here. So 2d. So d is 12v. So that is 24v then equals 6v plus half. What is the force? So that is 3 Newton. 3 divided by the mass of the object is 2 multiplied by 36. Let us simplify this. So this is 18v. That equals 36 divided by 4. So 9 times 3, that is 27. So this will give you the value of v, right? So that is 3 by 2. So we got the value of v, right? that can be substituted here to get the value of d, that's it. So this gives the value of d. So that is, so v multiplied by, so 3 by 2 multiplied by 12, so that is 18. So that's all. So 18 meter, so that is our required distance. Do you understand? So there are two cases. The first one, we have the constant speed, so we can directly write the relation distance equal to speed multiplied by the time. But in the second case, there is an acceleration, okay, acceleration. So this is the formula that relates speed, time and the acceleration, right? So using this formula, we get our required answer, 18 meters, okay. The force required to stop a car of mass 1500 kg moving with the speed of 36 km per hour in 3 seconds is. Here a car is moving with the speed of 36 km per hour. Our Tintu is trying to stop the car. What is the amount of force applied by him to stop the car in 3 seconds? The car is moving with certain speed. That is the initial speed of the car. The final speed of the car is 0. When it stops, the speed is 0. So initial speed is known, final speed is known, acceleration we have to find. See, acceleration and force are related. So when you find the acceleration, we can find the force also. Alright, let us find the acceleration. Yes. Now, what is the initial speed? So that is 36 km per hour. Let us take that as u. So that is the initial speed. So that is 36 km per hour. Let us convert this into meter per second, right? So 36 km per hour. So what is the method to convert into meter per second? Multiply by 5 by 18, right? Then it gets converted into meter per second. So meter per second. So 36 multiplied by 5 by 18. So that is 10. So 10 meter per second. So that is the initial speed of the car, right? U. So what is the final speed of the car? So V. So that is 0, right? Because the car comes to halt, right? 0. Now we have to find the acceleration. Let us find the acceleration. Yes. Now what is the relation between speed and the initial speed, final speed and the acceleration? So this is the formula we're going to use. So V equals U plus AT. Okay. So that's all. So substitute the values here. So 0 equals U. So that is 10 plus A multiplied by T. So the time is also given. So 3 seconds. So 3. That'll give you our acceleration. So what is acceleration here? So minus 10 divided by 3, so meter per second square. So this is the acceleration. Now we can find the force. So what is force? So force equals mass times the acceleration. So mass of the car, so that is given, so that is 1500 multiplied by the acceleration, so that is found here to be minus 10 by 3. So that's it. This is 500 multiplied by 10. So minus 5000 Newton. So that's it. So that is the amount of force to be applied to stop the car in that given time limit, right? So 3 seconds, right? So that is our required answer. Okay.
But we are getting negative 5,000.
See, the negative sign doesn't matter. We just need the magnitude of the force, so that is 5000 Newton, right? We are getting negative sign because we apply the force in the direction opposite to the direction of motion of the object. The object is moving in one direction, but we apply the force in the opposite direction. That's why we are getting a negative sign. Alright, so now we'll also do this question by another method. See, we have written the relation between force and momentum, right? So force equals the rate of change of momentum at a particular, right? This is just another way to do it, right? Alternative. Now force equals the rate of change of momentum. So this is the force at a particular instant of time. Suppose this force is a constant force, okay, this force is constant, or if the force is not constant but we only need the average force. In any case, either the force is a constant force or we just need the average force. In that case, we can use this formula, delta P, that is the change in momentum divided by the change in time. Okay, so this can be used, right? If you just need the average force in that time period, right? Delta T is the time period. In that time period, what is the force applied, right? So that force is change in momentum. What is change in momentum? The final momentum minus the initial momentum. What is final momentum? Mass multiplied by the velocity, right? But the speed is 0, right? The final speed is 0. So that means the mass multiplied by 0. So that is the final momentum minus the mass multiplied by the initial speed. So the initial speed is known, so that is 10. So this is the change in momentum, right? The final momentum minus initial momentum, right? mv divided by the change in time. So that means the time duration. So that is 3 seconds. So 3. So that gives you our required answer, right? This is m. So the mass of the object, which is minus 1500 multiplied by 10 divided by 3. So that equals minus 5000 Newton, right? So that is the required answer. So this method can also be used to write the change in momentum divided by the time. So we know the time period and also the change in momentum, right? The change in speed is known and change in momentum can be found. So change in momentum divided by the change in time, right? That is the required force. Do you understand? So this is our required answer, 5000 Newton. A bullet of mass 20 gram penetrates a mud wall of thickness 20 cm with a speed 1 meter per second. The wall offers a mean resistance of 2.5 times 10 to the power minus 2 Newton. The speed with which the bullet emerges from the other side of the wall is. Here a bullet hits a wall. What will happen? There will be a change in the speed of the bullet due to the resistance of the wall. What is resistance? That is a force against the motion of the object. The bullet is moving in this direction. There will be resistance due to the wall in the opposite direction. So the speed decreases. That decreased speed is what we need to find, right? The initial speed of the bullet is given 1 meter per second. Now we have to find the final speed. U is given, we have to find V. That's all, right? And the acceleration is known. Because the force is given, we can find the acceleration. The force is in the opposite direction, right? So force is known, acceleration can be found. So initial speed is known, final speed we have to find, right? So let us find it. See, this is what is given, U. The initial speed of the bullet, that is 1 meter per second. What we need to find is the final speed. So V is what we need to find. Okay, let us find the acceleration. What is the acceleration? That is force divided by the mass of the object, right? What is the force here? So that is 2.5 multiplied by 10 to the power minus 2. That is the force, but the force is in the opposite direction. So minus. So minus 2.5 times 10 to the power minus 2. This is the force divided by mass of the object, right? Mass of the bullet. So that is 20 grams. So multiply by 10 to the power minus 3, right? We have to convert this into kilogram, right? So this is the acceleration of the object. Let us simplify this. So this is 25 divided by, okay, so this is minus 1.25. So that's all. So this is the acceleration of the object, right? Yes. Now acceleration is found. So let us relate this initial and the final speed. What is the formula which relates these two? So V squared equals U squared plus 2AS, right? We are using this formula because time is not known but the distance is known, right? So distance is known, initial and final speed are known. So let us substitute these values here. So this is what we need to find. So V squared equals, so U squared, so that is 1 squared plus 2, the acceleration, this one minus 1.25 multiplied by the distance. So that distance is the thickness of the wall, right? So that is given to be 20 centimeter, right? So that we can substitute here. So 20 centimeter. So convert that into meter, 10 to the power minus 2. Okay, yes, that's it. So let's simplify this. So V squared equals, so 1.25. Yes, 2 multiplied. This is 2.5 multiplied by 2. So that is 5. So that's all. So we get the answer 0.5. Alright, so this is V squared, right? V squared is found, we have to find V. So V is equal to square root of 0.5. What is the square root of 0.5? Approximately, see, square root of 0.49, that is 0.7, right? 7 squared is 49. So 0.49 has square root 0.7 approximately. So it is very close to 0.49. So we can take this value to be approximately 0.7, right? So that is our final speed, okay? Because 7 squared is 49, right? It is very close to 50. So that's all. So 0.7. So that is the final speed. That means the speed with which our bullet emerges from the other side of the wall, right? So that is our required answer.
Can it be done by the momentum method?
See, that formula requires the change in momentum divided by the time duration. Change in momentum can be found because we know the initial speed, final speed. So mass times the speed will give you the momentum. So change in momentum delta P is known. But what is the time duration? We don't know, right? We only have the distance here. So 20 centimeters is the distance. Instead of distance, if you had the time, so we could have found it by that method also, right? Or we have to first find time using the distance and then we have to use that formula, but instead this is the better method, right? So directly we can find it, right? We have the relation between initial and final speed, so acceleration is known, so directly we can use this method to find the answer. Okay, yes. An object of mass 2 kg is moving at a speed 2 meter per second. A 4 Newton force is applied on the object along its motion. A 3 Newton force is applied in the perpendicular direction. The displacement in 4 seconds is. Here also we have an object moving at a certain speed and a force is applied, so there will be an acceleration. So the acceleration of the object is known and the initial speed of the object is also known. We have to find the displacement in 4 seconds. Alright, let us first find the acceleration. Force is given, not one force but two forces are applied. There is a 4 Newton force in one direction and also a 3 Newton force is applied in the perpendicular direction. One of the methods is to consider the two directions separately. let us consider this direction to be horizontal. A 4 Newton force is applied in this direction. So let us find the displacement only in the horizontal direction. Okay, let us find that first. So let us consider the first case, the horizontal direction. Okay, so in the horizontal direction, what is the initial velocity? So the initial speed is taken as u in the horizontal direction, that is given to be 5 meter per second. So u is 5. Okay, and also the force in that direction is also known. So that is 4 Newton. Now we have to find the acceleration. What is acceleration? Force divided by the mass of the object. So that is 4 divided by mass of the object is given. So that is 2. So that means 2. Right, so 2 meter per second square, that is the acceleration in the horizontal direction. So we got the acceleration and we have the initial speed. Let us find the displacement in only in the horizontal direction. Okay, let us find. So let us use the same formula, S equals so ut plus half a t square. So S is the displacement in the horizontal direction. So let us take that to be x. Okay, x is the distance in the horizontal direction. Now u is known, so 5 and 4 seconds. We want the displacement in 4 seconds. So 1 by 2, the acceleration is found here, 2 multiplied by t square. So that is 4 square. Alright, so let's simplify this. So this is 20 plus 16. So that is 36. 36 meters. So that is the displacement in the horizontal direction only. Right. Now let us find the displacement in the perpendicular direction or the vertical direction. Alright, yes, let us find. What is the initial speed? Initially, the object is moving only in the horizontal direction. 5 meter per second. There is no vertical motion, right? Initial speed in the vertical direction is 0. So u is 0 here. And let us find the force is also given in the vertical direction. So that is 3. So force is known. Let us find the acceleration. So force divided by the mass. So that is 3 by 2. So we got the acceleration. Again, same formula can be used here. So S equal to ut plus half at square. But this time the displacement, let's take it as y. So y equals ut. So u is 0, right? So 0 plus half a t square. So a acceleration is known. So that is 3 by 2 t square. So t square is 4 square. Alright. So this is, so we got the value of y here. So 4 multiplied by 3, 12 is the value of y, which means there is a displacement of 36 meter in horizontal direction and also a displacement of 12 meter in the vertical direction. Now what is the total displacement? So we've got something like this. So 36 is the value of x and also this 12 is the value of y. Now our required displacement S equal to 9. Pythagoras theorem, right? It's a right angle triangle. So let us use this Pythagoras theorem. So required distance S equals square root of x square plus y square. Okay, so that equals, so let us simplify this, square root of 36 square plus 12 square. So 36 square plus 12 square. So if you take 12 out, you will get, so this is 3 square, so 9 plus 1, 10. So 12 root 10. So that is our required displacement. Do you understand? So let us consider, so we have considered the two directions separately. Alright, horizontal direction and vertical direction, and finally we got the total displacement. So that is 12 root 10. So that is the answer. We can also do this question by another method. Instead of considering these two directions separately, we can consider them together. So that is a vector form. Alright, yes. Alternatively, we can do by this method. So that is the use of vector, right? We need not consider all the directions separately. We can consider a vector form of the initial speed, the acceleration, everything, right? Yes. What is the initial speed? It is only in one direction, horizontal direction. So let us take this horizontal direction to be I cap, right? Along x-axis. So I cap is the direction. So what is the initial velocity then? So u, the initial velocity. Vector form, so u equals, so that is 5 I cap. So horizontal direction only, no vertical initial velocity, right? Yes, only horizontal direction, 5 I cap, right? Yes. Now what is the force? So the force has also two components, 4 unit in the horizontal direction, so 4 I cap, and similarly 3 j cap, right? 4 I cap plus 3 j cap, 4 I cap plus 3 j cap. So that is the force vector. Okay, now we can find the acceleration vector. So the acceleration vector equals the force vector, so force divided by the mass of the object. Okay, so 4 I cap plus 3 j cap divided by, so the mass of the object is 2. So this is the acceleration vector. Now we can find the displacement. So what is the displacement? That is also in the vector form. So the displacement vector equals, so u vector t. Okay, now we are writing the vector form of the equation of motion. So u vector t plus half a t squared. So half a again is a vector, a t squared. Okay, so that's all. Let us substitute these values here. So u vector, so that is 5 I cap t. T is 4 seconds plus half a vector. So a vector is 4 I cap plus 3 j cap divided by 2 t square. T square is again 4 square. Alright, so let us simplify this. So this is 20 I cap, right? 20 I cap, and here also we have, let's simplify this. So 20 I cap plus this is 4 I cap plus 3 j cap multiplied by, so this is 16 by 4. Yes, now that equals, so 20 I cap plus 16 I cap, so that is 36 I cap plus, so 3 times 4, so that is 12 j cap. So this is the displacement vector. So we got the answer in terms of the vector form, but we want the magnitude of the displacement, so that we can find the magnitude of this equals square root of, so this is a vector, right? We can find the magnitude, so that is 36 squared plus 12 squared, so same value, right? We will get 12 multiplied by root 10. So that's also 12 root 10, that is the required answer. Actually both are same method only. Instead of considering the two components, but we consider the two directions separately. Okay, these two directions are nothing but the two components of the vector. So both the methods are same, but vector method we can consider these two cases together. Alright, in any case, so we get the answer 12 root 10. Okay. Two forces of magnitudes 2f and 3f are inclined at an angle theta between them. If 3f force is double, the resultant also gets double. The value of theta is. This is more of a vector question. It has nothing much to do with force, except that force is a vector. We just use the concept of vector here, right? There are two forces, which means two vectors, right? There is the resultant of these two forces, and in the next case, one of these forces is double. So what will be the resultant, right? There is a relation between the resultants in these two cases. Now using that, we have to find the angle between these two vectors, right? Yes. Now when there are two vectors, what is the resultant vector? The magnitude of the resultant. So this is the formula that you should be familiar with. So there is a vector, say call it say f1 vector. So that is first force. And there is another vector, say f2 vector. Angle between them is theta, and these two forces have some resultant r. So what is the magnitude of this resultant? So this is the formula that you should be familiar with. So the resultant of these two forces, so that equals the magnitude of the first vector, so f1 square, okay, and similarly f2 square plus 2 f1 f2 cos of the angle between them. So this is the formula for the resultant of two vectors. Whether it is force or any other vector, the resultant of two vectors is simply found by this formula. Okay, now let us find the resultant in the first case. Let us take it as r1, right? R1 is the resultant in the first case. So r1 equals square root of the first vector, right? So that is 2f, so 2f square plus the next vector, so that is 3f, so 3f square plus 2f1 f2, so that means 2f 3f multiplied by the cos of the angle between them, cos theta, right? So this is the resultant in the first case, right? Let us simplify this. So f square, the f square can be taken out, so this is f square root of, so this is 4 plus 9, right? 4 plus 9, let's simplify this. 4 plus 9 plus 4 multiplied by 3, so 12 cos theta. So we get f square root of 4 plus 9, which is 13 plus 12 cos theta. So that is the resultant of these two forces in the first case. Now in the second case, instead of 3f force, we have 6f, right? And the resultant also becomes 2 times the resultant in this case. Alright, so let us use that relation. Same formula can be used. So let us find R2 here. So what is R2? So 2f, that is same, 2f square plus, instead of 3f we have 6f, 6f square plus 2 multiplied by 2f, 3f multiplied by, the angle is same in these two cases, so cos theta, right? So let's simplify this. Again we can take this f out. So we get, this is 4 plus 36, so that is 40 plus, so this is 4 multiplied by 3. Okay, so here it is 6 again, right? So 6, not 3, right? In the second case, the force is 2f and 6f. So 6 multiplied by 4, so that is 24 cos theta. But here in this question, it is given that the resultant in the second case, R2, is 2 times the resultant in the first case, right? R2 is 2 times R1. So let us relate them, right? Now R2 equals, so R2 is 4, so f multiplied by the square root of 40 plus 24 cos theta. So that equals 2 multiplied by, that is R1, so that is 4 plus, sorry, 13 plus 12 cos theta. So that's it. Let's simplify to get this answer. That is 40 plus 24 cos theta. So 40 plus 24 cos theta. So that equals, so we can square these two equations, right? So we have to cancel this 4 multiplied by 13 plus 12 cos theta. Okay, that'll give you the value of cos theta. Cos theta equals, right? Yes, now 40 minus, that is 4 multiplied by 13, so that is 52, so 12. So minus 12 divided by, okay, so 4 multiplied by 48, 24, so minus 24, that means minus 1 by 2. Okay, so 12 divided by 24, so that is minus 1 by 2. So cos theta is minus 1 by 2. That means what is the value of theta, right? Cos theta is 1 by 2, so then the value is 60 degrees, right? Now here it is negative, so second quadrant, 180 minus 60 degrees, so that is 120 degrees, right? So that's all. So this is the answer, right? The theta value, the angle between these two forces. So that is our answer, right? The time bearing force F equal to 60 Newton is applied on a block of mass 5 kg at rest at an angle 60 degree with the horizontal. The horizontal distance covered by the object in 10 seconds is. Here a force is applied on the object, so there will be an acceleration. We have to find the displacement. Not in the direction of the force, we have to find the displacement in the horizontal direction only, but the force is applied in a different direction. So we can't use the force directly. We have to use the component of the force in the direction of the displacement. The object is moving in some direction, but we only need the displacement in the horizontal direction only. So instead of using this force as such, we will use only the component of the force in the direction required, right? So we only need the horizontal direction, right? So let us find the component of the force in the horizontal direction. So 6 Newton force is not what we need. So we need the force in the horizontal component of the force. The horizontal component of the force F, that equals, so the force is 60, right? 60, that is a variable force, right? 60, that is time dependent force. So 60 is the force, so that's not what we need. We need the force only in the horizontal direction, so multiply by cos 60. So that is the way to take the component, right? Multiply the force or the vector by the component, right? Cos 60 degrees. Here the angle is 60 degree, so multiply by cos 60 degree. So this is the force we need. Okay, so that is equal to, so cos 60 is 1 by 2, that means 3t. So 3t is the force, so that acts in the direction required. Okay, so that is the force. Force is known. Okay, now we can find the acceleration. So what is the acceleration? Force divided by the mass of the object, so that means 3t divided by, so the mass of the object is 5 kilograms, so 5. So 3t by 5 is the acceleration. Now we've got the acceleration. Now we have to find the displacement. How will you find the displacement using acceleration?
S equals ut plus half at squared.
See, all these formulae like S equal to ut plus half at squared, V equals u plus at, all these formulae work only for constant acceleration. The acceleration A there is a constant value, but here we got acceleration, a variable, right? A time dependent acceleration. So we can't use that formula. So we have to use the basic calculus, right? Differentiation and integration, right? So let us use the calculus, not the formula directly. So what is acceleration? That is the rate of change of velocity, right? So that means this acceleration can be written as, so dv by dt. Okay, so dv by dt is 3t divided by 5. So dv equals, so 3t by 5 dt. Now we have to do integration to get the velocity, right? So initially the velocity is 0. Now at some point of time the velocity is taken as v. Similarly this can be taken from 0 to t. Okay, so let us integrate this to get the value of this v, right? The velocity at a particular time. So this is 3t squared by 2. So 3t squared divided by 10. So this is the velocity, so that is also a function of time only, right? Now we want the displacement. So what is velocity? The rate of change of the displacement, right? So we can write this v as dx by dt. So that equals to 3t squared divided by 10. So dx by dt. Now again we can do the integration to get the value of x, right? So that means we are getting dx. So dx equals, so 3t squared by 10 dt. Okay, yes. Now let us do the integration again. So 0 to the displacement x. Now here 0 to the time. Okay, yes. So that gives you the value of x. So this is 3t cube by 3. So this is t cube divided by 10. So that is the displacement. Okay, in time t. Okay, but the time is given here, right? 10 seconds. That can be substituted here. So t is equal to 10. So that'll give you the value of x. So that is 10 cube divided by 10. So that is 100. So meter. So that is our required answer, right? X. See, there are two things we have used here. One thing is the force is not in the direction of displacement that we need, right? We need the displacement only in the horizontal direction, but force is in a different direction. So we have to take the component of the force in the required direction. So we have multiplied by cos of the angle, right? Cos 60 is multiplied with the force. That is one thing. And also it is a variable force or variable acceleration. So the basic formula or the equations of motion, so they don't work. We have to use calculus, right? We have to do integration, right, to get our required displacement. Okay, so the answer is this 100 meter, right? An object of mass 12 kg is moving at a speed of 4 meter per second. A force acts on it for 6 seconds, turning its direction by 90 degrees and reducing its speed by 1 meter per second. The average force on the object is. Here an object is moving at a speed of 4 meter per second and a force is applied, so the speed of the object is reduced. Not only that, the direction also changes to the perpendicular direction. So the directions are different, right, in these two cases. So we have to use the vector form, not the scalar form, right? So the final velocity is known, initial velocity is known in the vector form, and then we can find the acceleration. So what is the relation between the final velocity and initial velocity? So this is the formula that relates the initial and final velocities, right? So v equals u plus at. Okay, yes. Now we have to use the vector form. So the directions are different, right, v and u. So we have to use the vector form. So v vector equals u vector, similarly the acceleration vector, right? So what is the initial velocity vector? So that initial velocity has magnitude 4 in the direction of I cap. Let us take the horizontal direction to be I cap. So horizontal direction I cap, but the magnitude is 4. So that means this is 4 I cap. So that is the initial velocity vector. What is the final velocity? The magnitude is reduced by 1 unit. So that becomes 3 then. So initially the magnitude was 4. Now it is reduced to 3. Okay. And the direction is also changed. The direction was I cap. Now it is j cap. So 3 j cap. Acceleration is what we need to find. So the acceleration and the time is also known, right? 6 seconds. Okay. Now we got the acceleration. So what is the acceleration vector? That equals 3 j cap minus 4 I cap divided by 6. So this is the acceleration. From acceleration we can find the force vector. The force equals mass times the acceleration. So that equals, the mass of the object is known, so 12 kilograms multiplied by this one, 3 j cap minus 4 I cap divided by 6. So if you simplify, we get this vector. So this is 2. So 6 j cap minus 8 I cap. So this is the force vector. We only need the magnitude of this force, so we have to take the magnitude, right? Yes. So let us take the magnitude of this. So that is square root of 6 square plus 8 square, right? So that is the answer, right? So 6 square plus 8 square, so square root. So that can be calculated here. So that is so 2 square root of 3 square plus 4 square. So that equals, so 2 multiplied by 5, so that is 10. So 10 is the magnitude of the force, right, or the average force. Even if the force is not constant throughout that interval, so we can take the average force to be 10 Newton, right? So that is our required answer, right? Now we can also do this question by another method. We've already done this method. If you want to find the average force, we can use the change in momentum like this. So this is just an alternative method. So we know that the force, if it is constant, or we just need the average force, so that is the change in momentum divided by the time duration, right? So what is change in momentum? Mass multiplied by the initial mass multiplied by the velocity, right? So what is the final velocity? So that is this one, 3 j cap minus the initial velocity, so that is 4 I cap divided by, so the time duration, so that is 6 seconds, so 6. So that's all. So the mass is known already, so that is 12, 3 j cap minus 4 I cap divided by 6. So that will give you our required answer. So that is minus 8 I cap. So this is the force vector, okay, force vector. So if you write the vector form here, we are writing the vector form, so that is the momentum vector. So F vector is known, so to find F we have to just take the magnitude of this. So magnitude of this equals square plus 8 square, so that is 10. Okay, so that is our required answer. You understand? So either we can use that change in momentum method, or this is the direct equation of motion but in the vector form. Okay, so the answer is this 10. 40 bullets are fired in 15 seconds at a speed of 300 meter per second. The mass of each bullet is 20 gram. The average recoiling forces. When a bullet is fired, the pistol applies some force on the bullet. In return, the bullet also applies an equal amount of force on the pistol. So this reaction force is called a recoiling force, right, by Newton's third law. So this reaction force is equal in magnitude but opposite direction to the force on the bullet. So instead of finding the force on the pistol, we can find the force on the bullet, but not one bullet, 40 bullets. So let us find the force using the change in momentum, because we know the initial speed, final speed. Let us use the change in momentum formula to find the average force, right? So what is the force? What is the initial speed of the bullet? That is 0, right? Initially the speed of the bullet is 0. Now the final speed, so that is the speed of the bullet, so that is given to be 300 meter per second. So initial speed, final speed are known. Let us find the force or the average force. So that equals the change in momentum, so delta P divided by the time, delta T. Okay, what is change in momentum? The initial final momentum minus initial momentum, mass multiplied by V. So that is the final momentum minus the initial momentum, mass multiplied by the initial speed, that is u, divided by the time. So let us substitute these values here. So the mass of each bullet, so that is given to be 20 grams. So that means 20 multiplied by 10 to the power minus 3, converting that into kilogram, right? Yes. Now we've got the mass of each bullet. Now we have 40 bullets, so this should be multiplied by 40, right? So totally we have 40 bullets, each one having mass this, so multiplied by 40. So V minus U, so V is known 300 minus U is 0. So that's all, divided by, so the time, so that is 15 seconds, right? 40 bullets in 15 seconds, so divided by 15. All right, so let us simplify this to get our required answer, right? So 300 divided by 15, so that is 20, 40, 20. So that equals, let me write it, 20 multiplied by 40 multiplied by 20 multiplied by 10 to the power minus 3. So that equals, so 2 multiplied by 4, so it is 16. So 16 Newton, so that is the force on the bullets, right? But that is the same force on the pistol also, so that is the recoiling force. Do you understand? So that is our answer, 16 Newton. Okay. A ball of mass m dropped from a height h rebounds to half the distance. The ball is in contact with the ground for 0.5 seconds. The average force exerted by the ground on the ball is. When a ball is dropped from a height, the speed of the ball increases because there is a downward gravitational force or downward acceleration. So the speed increases until the ball hits the ground. When the ball touches the ground applies a force in the opposite direction. That's why the ball rebounds, right? So this change in velocity, the direction of velocity changes, right? Initially the ball was moving in the downward direction, now it is moving in the upward direction. This change in velocity or this change in momentum is due to the force applied by the ground. So that force is what we need to find. But the ground applies the force only in the duration of time when the ball is in contact with the ground, right? So that is 0.5 seconds. So in that duration, the ground applies a force on the ball, right? That force is what we need to find. So like we did in the last question, we will find the change in momentum. What is change in momentum? See, initially, that means before the ball touches the ground, what is the momentum? Let us find the initial momentum. Then after it leaves contact with the floor, what is the momentum? So that change in momentum divided by the time duration, that will give you our required force. Alright, so let us use the same idea here. So what is the initial speed? Initial speed means before the ball touches the ground, so what is the speed of the ball, right? So that is, so this formula you are supposed to remember. When a ball is dropped from a height, what is the maximum speed? Maximum speed means the speed just before the ball touches the ground. What is the maximum speed? So the ball is dropped from a height h. So the speed when it touches the ground, so that is square root of 2gh, right? So hope you remember this formula. So this is the speed or the maximum speed when the ball is dropped from a height h. Do you understand? So that is the initial speed. So that means what is the initial momentum? So we can find the initial momentum multiplying this by the mass of the object. Okay, anyway, that we can do later. Now let us find the final speed. See, by final speed, I only mean the speed just after the ball leaves contact with the floor, right? Do you understand? This initial speed is the speed just before it touches the ground. So what is the final speed? But this time the ball rebounds only to half the distance. So that means same formula can be used, square root of 2gh, but h is h by 2 here, only half the distance, not the same height. So the final speed v equals square root of 2g multiplied by not h by 2. You understand? In the first case, the distance or the height was h. Now the height is h by 2. So the speed also changes. So this is the final speed. So we can write it as square root of gh. So that is the final speed. So we've got initial speed, final speed, so we can find the change in momentum. So using that we can find the force, right? But when you calculate momentum, the direction is important. So this is only the speed, that means only the magnitude of the velocity, these two, but direction is also important because so these two are in different directions. So one is in the downward direction, one is in the upward direction. So let us take the upward direction to be the positive direction. So upward direction is taken to be positive. That means what is the final velocity? So that is plus root gh, right? Positive only. But what is the initial velocity? So that is negative, minus root 2gh, because we take the upward direction to be positive. Suppose you take the upward direction positive. Any direction you can take negative or positive. This is positive. So this is negative. So that sign is also important when you calculate the momentum. So what is the formula for force? So delta P divided by delta T. So that equals the final momentum. What is final momentum? Mass multiplied by, this is the final speed, mv, minus the initial momentum is mass multiplied by, but minus, remember the initial momentum is negative because it is in the opposite direction. So minus mu divided by the time. So that equals, so m if you take common, so this is v plus u divided by t. So that's all. So we've got all these values. We can simply substitute here to get our required answer. So the mass of the object is known, so m only, and v and u, t, everything is known. So we simply have to substitute. So what is the value of v? So that is root gh. That is plus 2 root 2gh divided by t. So t is 0.5. That means we can simplify this, 0.5, 1 by 2. So that is 2m. Root gh can be taken out, root 2 plus 1. That's all. So that is our required answer, right? The change in momentum divided by time. So that is the force exerted by this ground on the ball, right? So that is our required answer. A barrel containing water is pushed from rest along the smooth ground with force of 6 Newton. Water is leaking at a rate of 0.5 kg per second. If the initial mass is 12 kg, the speed after 6 seconds is. Here a barrel containing some water is pushed by a force of 6 Newton. We have to find the speed of this object after 6 seconds. Here the water in the barrel is leaking at some rate, right? Now we have to first find the acceleration of this object. So force is given. How to find the acceleration?
Force divided by mass.
See, that formula, force equal to mass times acceleration, works only when the mass of the object is constant. See, what is the fundamental form of Newton's second law? The force equal to the rate of change of linear momentum. So the linear momentum is mass times the velocity. Its rate of change is mass times the acceleration, only when m is constant, right? When the mass is variable, like in this case, the water is leaking, that means the mass is decreasing. So it is a variable mass case. So in that case, we can't use the formula force equal to mass times acceleration. You have to use the formula force equal to the rate of change of linear momentum. Okay. So far we have done questions only with the constant mass. So this is the only question we do with the variable mass, right? So generally questions of this type, the variable mass case, are done as part of work energy, right? So now we will do just one question, right? Just for a change, one question with the variable mass, right? First of all, we will find the mass of the object at a particular instant of time, because it is not a constant. So we will find the mass in terms of the time t. Okay, yes. What is given? The rate of change of mass. So that is given 0.5. So that is the rate at which the water is leaking, which means the mass decreases at that rate. So what is rate of change of mass? So that is denoted by dm by dt. So that is the rate of change of mass. So that is minus, because it is decreasing. So minus 0.5, this is dm by dt. Okay, now let us find m. So we have to do some integration here. So dm equals minus 0.5 dt. So let us do the integration. So the initial mass is given, so that is 12, right? So 12 kilogram, that is the initial mass, and the mass at a particular instant, so that is m, and the time, so 0 to t. Okay, so this is m minus 12, so that equals, so this is minus 0.5 t. So we get the value of m, so that is 12 minus 0.5 t. So that's also, this is the mass of the object at a particular instant of time, right? So when t is 0, so what is the mass? 12. So that is the initial mass, right? Then the mass keeps decreasing, right? So when t is increasing, the mass of the object is decreasing, right? Yes. Now we got the mass. Now we have to use the Newton's second law. So what is Newton's second law? So the force equals the rate of change of linear momentum. So d by dt of mv, right? So usually m is constant, we can take it out, so dv by dt, but here m is also variable, you have to use the product rule of differentiation. M multiplied by the derivative of v multiplied by the derivative of m, so this is m multiplied by dv by dt plus v multiplied by dm by dt. So dm by dt is usually constant, okay, when the mass is constant. I mean dm by dt is 0 when the mass is constant. So this term goes off, so only m multiplied by a, so that is the formula. But here we also have this non-zero term. So force is given here to be 6 Newton and the mass is found here. So we can substitute this mass. So 6 equal to, so the mass here is 12 minus 0.5 t dv by dt plus v multiplied by dm by dt. So that is also known, it is minus 0.5. Okay, so we've got a relation between v and t, right? Integrating this, we will get the relation between v and t. Let us do the integration. So if you simplify this, we'll get, so 6 plus 0.5v, right? So that is dv by 6 plus 0.5v. That equals dt divided by 12 minus 0.5. Okay, yes, now we have to do the integration. So integration of this, so initially the speed is 0 v and then this is from 0 to t. Okay, let us do the integration. What is the integration? 1 by 6 plus 0.5 v, so that is ln of this one, right? So log base e of this value, and v is multiplied by 0.5, that means it is 1 divided by 0.5 log of this value, 6 plus 0.5 v, and then we have to substitute the limits, 0 to v. So that equals, similarly this integration, this minus, so minus 1 by 0.5 multiplied by log of, so 12 minus 0.5 t, then the limit is from 0 to t. Okay, so let's simplify this. So this 0.5, so that can be cancelled, so we get log of, v is substituted here, 6 plus 0.5 v, minus, if you substitute the lower limit, it is log of 6, so minus log 6, so that can be written as log of this divided by 6, right? So we use the log formula, log a minus log b, that is log a by b. So that equals, similarly here, minus log of 12 minus 0.5 t, and if you substitute 0, we get 12, so that is the value. Okay, now, so this minus can be taken in, so this becomes the reciprocal, right? The minus of log of this value equals log of the reciprocal, 12 divided by 12 minus 0.5 t, so log of this value equal to log of this value, so we can remove that log, right? So we can simply write 6 plus 0.5 v divided by 6, so that equals, so because of this minus, this becomes the reciprocal, so that is 12 divided by 12 minus 0.5 t. Okay, so that's how, this is the relation between v and t, but t is given in the question, right? 6 seconds, so that can be substituted here. So t is 6, so this will become 6 plus 0.5 v equals, so 6 multiplied by 12, right? So that is 72 divided by, and 6, so 12 minus 6 multiplied by 0.5, so that is 3, so 9. Okay, so 6 plus 0.5 v equals 72 divided by 9, so that is 8, so that will give you the value of v. So it is 2 divided by 1 by 2, so that is 4, so 4 meter per second. So that's all. So that is our required speed at a time when t is equal to 6, right? Yes, so that is our required answer. So there are two things we have to do. First of all, we have to find the mass of the object at a particular instant of time. Because it is not a constant, you will get the mass in terms of the time t. So that's what we found here. So mass is written in terms of the time t. Okay, now we have to use the formula, the basic form of Newton's second law, right? So what is Newton's second law? The force equal to the rate of change of the linear momentum, where m is a variable here, not a constant. So we have to use the product rule, and we found the relation between v and t, right? The velocity in terms of the time, but the time is given. Substituting that, we get the value of t, v, right? So v is equal to 4 meter per second. So that is the answer. So we have completed the basics of Newton's law. The rest of the chapter is about different types of forces, like the normal reaction, the tension force, frictional force, pseudo force, etc. In the next class we will do the gravitational force. Okay.